Today we're doing 3.1 sequence of transformations, and essentially you guys have done this stuff before. These are just our basic transformations. So we have translation, rotation, reflection, but we're going to sync them up in series, so we'll do maybe 2 or 3 of them at a time, or at least one after another. So you'll see some examples here. For this one here, it basically says the first step is a reflection over line L, and then a translation along vector V. So here's the image right here, ABC. We're going to reflect it over L, and then we're going to translate it along the vector. So how to do that? Well, we just break it down into 2 steps. So the first step is our reflection. Oh, sorry, this is kind of hidden. There you go. So we do the reflection step, right? We put B over here, poink. C prime's over here, A prime's right there. And then after we've done that step, we do our translation along this vector. This vector is over 4 units up 1, so we take each point, put it over 4 up 1, and that gives us our translation. So we just do one, and then we do the other. Note here, after our pre-image, which just has letters for points, we have A prime, B prime, and C prime. When we transform that image, that image to a second image, we're going to add another prime mark. So you'd call that B double prime or C double prime, A double prime. So just remember those little tick marks there. Okay, so let's go ahead and do this one real quick. We'll do a 180-degree rotation around point P, and then a translation along vector V, and then a reflection across line L. So 180-degree rotation around point P. So here's point P. So C is here. So C prime would be right there. A is here. So A prime is right there. And B is here. B prime is right here. So we can go ahead and label these points. This is, what do we decide? C prime. C prime. And this one is A prime. And this one is B prime. And then we have nice, beautiful straight lines between each one because you're going to use a straight edge. Okay. So that's our first step. Second step, apply the translation along vector V. So what is vector V? Well, vector V is, let's see, 1, 2, 3, 4, 5. So if I were to write in component form, it'd be 5, comma, and then the vertical part, which is 1. So vector V would look something like this. But we apply it to this new image here. So we're going to go over 5, 1, 2, 3, 4, 5, up 1. So there's C double prime. Here's A, 1, 2, 3, 4, 5, up 1. There's A double prime, and B, 1, 2, 3, 4, 5, up 1. That's B double prime. So we can label this. There's B double prime. This one is, what, A double prime, A double prime, and this one is C double prime. Cool. And you do nice straight lines between each one. Nice, beautifully straight lines. Cool. And then finally, we do our reflection across line L. So here's line L, we reflect it across. That puts the point there. And then we go, let's see, A would be down 3, yep, and then B is 1, 2, 3, 4, so apart, so 1, 2, 3, 4, something like that. And then we can, I suppose I can label this one. So this is B triple prime, C triple prime, and A triple prime. 1, 2, 3, and I may have left the real one underneath. Oh, look at that. Cool. We did it right. Yeah, all those steps. See if you can do this one real quick. I'll answer that question. So pause. So yes, rigid transformations move the figure in the plane. They don't change size or shape. Let's just review. Number 5, does the order in which you apply the transformation make a difference? Tell me what you think. Yes, sometimes it won't, sometimes it will. Depends on a number of factors. But okay, see if you can do numbers 7 and 8. Okay, so 7 is a reflection across line L, so boop, and then a rotation around point P. So here's point P, and you rotate it up. I'm going to have to pause this. Hold on. Okay, sorry about that. So we've done our reflection across line L, and then we do a 90 rotation around point P. So just a reminder on how to do this. The easiest way is to just count the number of units over and up. So in this case, we count 1, 2, 3 units over, 1 unit up. So we're going to take that and we're just going to rotate it 90. That's make a little pinwheel shape there. And we'll rotate it. So we're going 3 units up and 1 unit over now. So, and then for number 8, we're going to do something similar. We're just going to translate along vector v. So here's our figure. We translate along this vector, vector v, boop, it pops us up there. Then we have 180-degree rotation. Again, we can just count, over 1 unit, up 1. So in that case, we'd go over 1 unit, down 1 here. For the other point, like E, we go up 3 over 1. So we go down 3 over 1. 1, not 2. And then, oops. And then for the last point, again, we can go over 2, up 3, over 2, up, sorry, up 2, over 2, up 2, like that. So pinwheels, just to count. Okay. We can also do non-rigid transformations. So non-rigid ones are basically dilations. And we've done dilations before. For example, this one here, we start with this small one. We do a dilation of 1.5, so it goes, it's 1.5 times bigger. We flip it over, and then we do a vector thing. So we'll try this one real quick. So we start with our little figure. Our first transformation here is we're going to do a stretch of a factor of what in which direction? Well, it's a factor of 3 horizontally, right? Because it's 3x y. So the y doesn't change, just the 3 does. So let's go ahead and apply this stretch. So A doesn't move. That's right there. So that's A prime. I'm going to relabel that A prime. Okay, and then we'll stretch B. So B ends up over here. And then we'll stretch C. And C will end up, let's see, that's horizontal value of -4. So it's -12. It's going to be way over here for C prime. So here's C prime. Here's B prime. And the whole thing looks like a nice straight line there. Nice straight line here. And then a nice straight line there. Yep. Okay. Second transformation is this one here. So 1/2 x, -1/2 y. So we're going to do 2 things. We're going to dilate it by 1/2, and then we're also going to do a reflection. In this case, we're reflecting it over the x-axis because the y is becoming switching the sign. So we can do that. We're going to flip it up here. So that would be we could list out the points too. Let's do it that way. So A prime is at what, 0, 2. B prime is at what, -6, -5, -6, -4. -6, -4, and then C prime is at -12, -4, 12, -4. So this is just another method you could do. Remember, we have our transformation here. These all become different values. In this case, 0, 2 after this transformation here of 1/2 x, -1/2 y, 1/2 of 0 is 0, and -1/2 of y is, oh shoot, that should have been -2. Oops. So we'll start with the -2. That's the correct value. And then we get a +1. Cool. Negative 6, 1/2 of that is negative 3, so negative 3. Half of 4 is 2, so it's positive 2. And then finally that gives us negative 6 and 2. So now we can graph these points. 0, 1 is right there. Negative 3, 2 is right here. And negative 6, 2 is right here. So it looks like for this is A prime, A double prime. Again, we'll try and get in the habit of labeling these. A double prime, this is B double prime, and this is C double prime. Okay, let's see if it worked. Yay, it worked. Okay, cool. Last question right here. Go ahead and see if you can figure this one out. Should look something like that for the first, something like that for the second. So this first one is simply a translation, right, along a vector of -1, -1. And then we do a horizontal stretch of 3 to get this one. And then finally we do a 180-degree rotation. This one here, we do a horizontal stretch of 1.5 and a vertical stretch of 2, and then flip it at the same time. So a lot going on there. That's a complicated transformation. And then we do a dilation, right? Or not a dilation, a translation. So we scoot it down and to the right. Again, for these complicated ones, I suggest that you just write out the points and then apply these properties to each point individually. Okay, that's it. That's all I got. Good luck.